So we are trying to find the coordinate direction angles of force 1. Force 1 being on this end of what is demonstrated in the picture. So this is my attempt to draw it. This is much more clearly drawn. So we have given the x-axis positively down here. We have the z going up positively, and to the right we have the y-axis positive. That only leaves for us to say that the negative z goes down, the negative y is this way, and what's important for the problem is the negative x goes this way in the direction at which this force goes. So in order to find the coordinate direction angles, we need to be able to take this information by looking at this picture and separate force vector 1 into 3 different components, which is the x-axis, the y-axis, and the z-axis at which these forces are acting. So we can dictate, or we can name these angles to be alpha, beta, and gamma in order to be able to state that these are the coordinate direction angles appropriately. So we have in force x, in the x-axis, we have the magnitude, which we are trying to put into this equation. So we have the magnitude, or the force, that is 300 newtons, so we put that in there. It is negative because, as stated down here, this is the negative x-axis, and we are looking at the x-axis over here. So we have a negative x-axis that is being there, so it's negative 300 multiplied by, this is a cosine of 30 because we are looking at the side over here that is right next to the x. The angle's right here in this corner, as I tried to draw over here, and it goes up. So it's the adjacent side, we have the cosine, we have the opposite side for the 45 degrees, which is over here. We have over here this sine angle over here that we are looking opposing to it, and that is why we have this f of x. This f of y is also a 300 because we are still looking at that same force. We have the cosine of 60 because it is adjacent to this still. It's still acting in that adjacent side. This side over here is not in the x or y, and we have to remember that for later on. We have this cosine of 45 over here because we are now looking at this adjacent side over here and over here. We are trying to find these. These is not in the adjacent side. That's why we cannot use sine. And over here for f of z, we have the 300 newtons as said before. And then remember how we had said that this over here was the opposing side and was not in the x or y? That is why it is in the z-axis. That's why it's over here, because we're looking over here. This is the y-axis. This would not be in the y-axis because it does not go in that same direction. And this, well, this is x, so we cannot dictate that as being in the z-axis. That is why we have 300 sine of 60. Now, in class we had previously said that the magnitude was found by the square root of a squared plus b squared plus c squared, or like the I, j, and k for the vector, actually saying the correct letters. But we don't need to do that. This is what not to do. You don't do that because this is not the magnitude that we need for this problem. What we have is the 300 newtons. These 300 newtons over here are being acted upon. This is the force. So because of that, we have the force over here, and because we need the coordinate direction angles, we are looking distinctly for a unit vector. Unit vectors having the magnitude of 1. That is why we can divide by 300. We need that magnitude of 1 in order to define the coordinate direction angles appropriately. And then also, because this is the force that is acting upon it, we can also state that this is the magnitude of said force. So we have the negative, this cancels, cosine 60, sine 45, and this is all within the parentheses for arc cosine. Same thing over here, this 300 cancels, so we have cosine 60, cosine 45. Then over here, these 300 cancel, so we are just left with sine of 60. When input into my calculator, I got 110.7 degrees, 69.3 degrees, and 30 degrees for the respective alpha, beta, and gamma.